Okay, in this example, we're going to look at chemical naming, and so we're going to work on filling out this table. And so it has the cation, which is the positively charged ion, the anion, which is the negative, the chemical formula, and the name. So this is a good practice for things that we would expect to see on exam 1. So what we need in order to do this is the periodic table, as well as all of our known polyatomic ions, which come from the polyatomic ion table. Okay, so first we have lithium oxide, and so we know that lithium is going to be our cation, and so we can find lithium on the periodic table, and based on its location we know that it's Li+. We know that oxide is oxygen. Based on its location, it's an O2-, right? So the charges go on the top, and we want these to balance, and so in order to make a neutral molecule, we need 2 lithiums for every 1 oxygen. So we'll have Li2 oxygen, and that is lithium oxide. Okay, so next we have iron. We have a charged iron species, and this is phosphate. And so we can start with either the formula or the name, it doesn't matter. We'll do the formula first. So if we have a +2 and a -3, we know that we can't just use one of each, and so in order to do this, we're going to know, so a 2 and a 3, it turns out we can switch the subscripts, and so we'll have Fe3PO42. Now you'll have a couple of notes here. There are parentheses right here because there are 2 of these phosphate groups. We can't write P subscript 2, O subscript 8. That means something entirely different. Okay, so we need a parentheses if we have multiple of a polyatomic because they don't fall apart. So how do we name this? We know that it's iron and we know that it's phosphate, but it turns out for transition metals, which are the metals found here in our periodic table, we need to be able to distinguish between perhaps the +2 and the +3. So it's iron 2 phosphate. So the 2, so it could be any number from 1 to as high as 7, indicates the charge state of the metal ion. Okay, so next we have aluminum sulfate. So the name of this is aluminum sulfate. Okay, so there's a couple of different ways that we can come up with the cation and the anion. So we know that aluminum is the cation, and so what is the charge on that? When we look at our periodic table, based on its location, we know that it's Al3+. Okay, so what does this tell us about sulfate? So sulfate is one of our polyatomics, and so sulfates are SO4 2-, and so we can double check that these subscripts are correct based on the charges that we've ascertained. So this looks good. Next, we have copper 2 nitrate. Okay, so we're going to do the cation, the anion first, and then the formula. So when it says copper 2, we know that that means that the copper has a +2 charge because it is a transitional metal. So we have copper 2+. Okay, from here we can now see our anion, which is the nitrate, which is one of our polyatomics, which is NO3, with just 1-, and so we know that our formula has to balance the charges which are not currently balanced, and so we have copper with 2 nitrates. Again, we're going to use the parentheses here to make sure that we are indicating that there are 2 nitrates as opposed to 2 nitrogens and 6 oxygens. Last but not least, we have chromium 3+ and iodide. So we know that it's chromium iodide. Okay, but where is chromium on the periodic table? So it turns out that chromium is right here, and so because it's a transition metal, they usually have multiple states, and so we need to say what this is. It's just chromium 3 iodide. Okay, and so we need the molecular formula. So for every 1 chromium, we're going to need to have 3 iodide molecules. So we can have Cri3, which is chromium 3 iodide.